Hello. Hello and welcome to this video in which we will solve question number 51 to 60 of permutations and combinations. Please grab your pen and paper so that you can solve the problems with me. While I'm reading the problem, you should pause the video and try to work it out. And do not spend more than 15 minutes on a single question. If you get stuck, then either leave it and come back later or look at the solution if you can't do it in 15 minutes. So without further ado, let's get started. By the way, the link to download the PDF will be in description. And at the end, I'll show you how to download. So question 51 says that how many different words can be formed with 5 given letters, of which 3 are vowels and 2 are consonants? How many will have no 2 vowels together? So for 5 letters, total number of words is 5 factorial, that is 120. Now we consider the form of word when no 2 vowels are together. So we can write in V form, where C represents consonants and V represents the vowels. So as you can see, V can be arranged in 3 factorial ways and C can be arranged in 2 factorial ways. The total number of words where vowels are not together is 2 times 6, that is 12. Question 52 says that how many numbers greater than a million can be formed with the digits 2, 3, 0, 3, 4, 2, and 3. So there are 7 digits given and we have to form number greater than 1 million, which implies that all 7 digits have to be used. Among the given digits, 3 comes thrice and 2 comes twice. The total number of numbers which can be formed is 7 factorial by 3 factorial into 2 factorial. That is 420. These numbers will also contain where 0 is the first digit, making them less than 1 million. Number of such numbers is 6 factorial by 3 factorial minus 2 factorial is equal to 60. Hence, number of numbers greater than 1 million is 420 minus 60, that is 360. Question 53 says, in how many ways 5 Indians and 4 British can be seated at a round table if there is no restriction, all British sit together, all 4 British do not sit together, no 2 British sit together? The total number of persons is 5 plus 4, that is 9. With no restrictions, spelling mistake. With no restrictions, they can be seated in 9 minus 1 factorial, that is 8 factorial ways. Now the second part says when all British sit together. So we take all British as a single person, so we have 6 persons which can be seated in 5 factorial ways. But 4 British can be arranged among themselves in 4 factorial ways, making total number of ways as 5 factorial, 4 factorial. All 4 British do not sit together. So we subtract first 2 results and we get the answer 8 factorial minus 5 factorial into 4 factorial. No 2 British sit together. So we first seat the 5 Indians in 4 factorial ways. That leaves 5 positions open for Britishers between Indians, which gives us 5p4 ways. That's total number of ways in which no Britishers sit together is 4 factorial into 5 factorial. Question 54 says that in how many ways 5 Indians and 5 British can be seated along a circle so that they are alternated? The 5 Indians can be seated in a circle in 4 factorial ways. Then we will have 5 positions between Indians in which we can seat the 5 Britishers in 5p5, that is 5 factorial ways. So total number of required ways is 5 factorial into 4 factorial. Question 55 says that a round table conference is to be held between 20 delegates of 20 countries. In how many ways can they be seated if 2 particular delegates are always to sit together? So we take the 2 delegates as a single person. We have 19 persons which can be seated in 18 factorial ways. Now the 2 delegates can be arranged in 2 factorial ways. So the total number of ways is 18 factorial multiplied by 2 factorial. Question 56 says how many numbers of 4 digits can be formed with the digits 1, 2, 4, 5, 7 with no repetition? The total number of 4 digit numbers can be formed is 5p4, that is 120. This n should be capital. So we have two typing mistakes in 53 and 56. How many number of 5 digits can be formed with the digits 0, 1, 2, 3, and 4? So units place cannot be filled with 0. It can be filled in 4 ways using 1, 2, 3, 4. Rest 4 position can be filled in 4 factorial, that is 24 ways. So total number of 5-digit numbers is 96. Question 58 says how many numbers between 100 and 1000 can be formed with the digits 1, 2, 3, 4, 5, 6, and 7 with no repetitions. So number of given digits is 7 and we have to make numbers between 100 and 1000, that is 3-digit numbers. Since there is no 0 in the given digits, the required number of numbers is 73, that is 210. Question 59 says that how many numbers between 100 and 1000 can be formed with the digits 0, 2, 3, 4, 8, and 9? So 59. So units place can be filled in 5 ways, excluding 0, and 2 remaining places can be filled by remaining 5 digits in 5p2, that is 20 ways. So required number of numbers is 5 into 20, this should be 20, that is 100. Question 60 says that find the total number of 9-digit numbers which have all different digits. So we have to find all 9-digit numbers having different digits. So we have 10 digits, units place can be filled in 99 ways excluding 0. Rest 8 places can be filled using the remaining 9 digits in 9p8, that is 9 factorial ways. The total number of 9-digit numbers with no repetition is 9 multiplied by 9 factorial. So these are very easy questions, but they're important to build the base. So as we move forward, the problems will get harder. I hope that you have found this video useful and helpful for your studies. And let me show you how you can download the PDF. So either you click the link in description or come to my website astrowork.org, look at the date, whether the date is one you have downloaded or not. If the date is not that, and download again. Note that the file does not contain the date, because if I put date there, then I will have to go back in past and change my all YouTube descriptions if I put the date in the link actually. So the link does not contain date. There's trigonometry book also there. I'm working on coordinate geometry. Circles and pair of straight lines and pair of straight lines are done. Circles work has begun. As soon as circle is completed, I will upload the PDF here. So with this, I will say goodbye, and we will meet tomorrow around at the same time or maybe earlier with the 10 more problems, that is problem number 61 to 70, and then we see how we can solve those. So keep working hard, and I wish you best of luck for your studies and exams. See you in the next video. Till then, enjoy.